Hey, I know a lot of you are going to be gone tomorrow for a variety of reasons, so I am making a video of the lecture tonight so that you can get these notes on the day that you are gone. So we are doing notes for 3.1, and this is solving systems of equations by graphing. This PowerPoint is the exact one from class, so I'm going along with the guided notes if you have them. If not, you can come in and get them from me a different day. At the top of the page, it gives you some fill in the blanks. And what's going to go in those is systems of equations in ordered pair. So basically a system of equation is just two equations that have the same variables. We're almost always going to use x and y. To solve a system of equations, we're going to find the ordered pair that satisfies all of the equations. This is easier to see in examples, so I'm going to hop on to the next page. So if I want to solve this system of equations by graphing, the first thing I have to do is obviously graph them. I'm going to do that by putting these into slope-intercept form so they're easier to graph. That first one, I move the x over. You get negative 2y equals negative x. You divide both sides by negative 2, and you get y equals 1/2 1/2 x. I know that's not the best way to write that, but now at least you can see it. The second one here, I do the same thing. I move my x over, and I get y equals negative x plus 6. Once I've got both of those, I can graph them. Let's put this one in a different color so we can keep our lines separate. So to graph this first one, I'm just going to start at 0, 0 and go up 1 over 2, rise over run, up 1 over 2. And I'm going to continue that in this direction, but I'm also going to extend it out this way. So there's our first line. Now let's graph the second line. Let's put it in a different color there too. This one tells us we start at positive 6, so let's go up to 3, 6. And then it says we have a slope of negative 1. So down 1, over 1, down 1, over 1. And I'm just going to continue this. And then again, I'm going to extend it back. If you're drawing this on your paper, it's obviously going to look a little bit different because it's going to be easier for you to graph than it is for me on the computer. But once we have those graphed, we are looking for the ordered pair that satisfies those equations. So if I look here, I'm going to go over. I know it's hard to see, and because of how my lines are placed, it's challenging. It'll look a little bit clearer on your paper, I think. But I actually find that my solution is at 4, 2. So if I want to write the solution for this system of equations, I would just put the ordered pair 4, 2. And you'll also notice that these satisfy the equation, and we can double check that by plugging them into our original equation. So if I'm plugging them into the first one, 2 equals 1/2 times 4. Well, that works, so we are good to go. Check. Let's plug it into the second equation to make sure it satisfies that as well. 2 equals negative 4 plus 6. This ends up being 2. 2 equals 2. Check. So we for sure have found our point that satisfies the system of equations. So if you're looking for how to solve something graphically, the hardest part is making sure your graphs are right, and then just finding that coordinate pair. So here I've shown you again, that's just what the graph looks like. But I also know that not every single problem is going to give you the equations to work with. You may come across an example like this where you have to set the equation up. So a service club is selling copies of its holiday cookbook to raise funds for a project. The printer's setup charge is $200 and each book costs $2 to print. Well, if we are writing an equation for this, we need to talk about the cost to produce. And for the cost to produce, I'm going to say cost equals, and we're going to do it in our function notation form. I'm going to say C of x, because it's cost in terms of x, is the startup cost. plus the cost per book. So if I'm only modeling cost, this is going to be my equation. But it also says the cookbooks sell for $6 each. So in addition to cost, I can talk about revenue. If I'm talking about revenue, I'll say it in terms of X, but I'm going to use R as my variable. So for R of X, I get $6 per book, and there's no other cost associated. So there I have my two equations. Now to solve the system of equations, again, I'm just going to graph and figure out where these meet. Now, I went ahead onto this next page and I graphed it. But what you'll notice is if I scroll in really tight here, you can't get an exact number because your numbers over here on your y-axis are so big. So graphing is kind of going to be inaccurate or challenging at times. The easiest way to get around this, try some numbers. Let's plug in an X and see if we need to go higher or lower. If I plug in 25, what do I get for both equations? Well, for the first one, I get y equals 200 plus 2 times 25 is 50. So I get 200 plus 50 is 250. If I do revenue, I get y equals 6 times 25 or 150. Well, we don't know if that satisfies the equation because we still don't know what we're looking for. Notice in the problem it says how many books must the club sell before it makes a profit. Well, if your revenue is 150 and your cost to produce is 250, they're not making a profit, are they? So we're ideally actually looking for the number of books it takes for these two numbers to be equal. That's called the breaking point, because when those two numbers are equal, it means the expenses are balanced with the revenue, and once we get past that point, they will only be making profits, and it'll cost less to produce than it will to sell them. So 25 didn't work, so we're going to take all that off. If you're making notes on which ones you tried, you can say 25 too low. Well, you could probably guess what the answer is because of how I've graphed it, but if you couldn't, I'm also going to plug in 75. When I do that, I get 150 plus 200. So for expenses, I get y equals 350. If I plug in 75 for my revenue, I'm going to get 75 times 6, which is 450. Sorry, I'm having technical issues. So at this point, we are making profit, but we're pretty far over. So 75 is actually going to be too high. And if you don't automatically see it on the graph, it's a little bit like the Goldilocks idea, either too low, too high. So obviously, the nicest number is going to probably be that one in the middle at 50. And when I plug that in for my expenses, I get cost. I'll even put it in my function notation. Cost when I plug in 50 books is going to equal 200 plus 100, that's 300. My revenue when I plug in 50 books is going to be 300. So my breaking point, or the point at which I am making the same amount of profit as I am having expenses, is 50 books. And it's at that point where my expenses are $300 and my revenue is $300. So the point that I care about here is going to end up being 50 books, and I will be making the break-even point the breaking point will be 5,300, which is the amount of dollars at which they break even. So there's your final answer for that one. The last one I want to talk about is another one where you have to set it up. I won't be going through this one in quite as much detail, But location mapping needs a new software. If software A costs $10,000 plus $500 per additional site license, and software B costs $2,500 plus $1,200 per additional site license, write the two equations. Well, I've already done that for you. I said this one is going to be that original software cost plus the $500 per license, and the original software cost plus the license. When we go on to the next page, we're going to graph those just like we used to. And again, this is another one, because your numbers are so large on that y-axis, we're going to have to eyeball it. And I went to the work and I actually found out that it was about 10.7 additional licenses. But you can't sell 10.7 additional licenses. You can't sell 0.7 of something. So if we're estimating the break-even point, it looks like it's at about 10.7, but in all reality, we would have to sell 11 to actually break even, and we would have just a smidge amount of profit off after that break-even point. So, as long as you're okay with graphing and okay with practicing estimation on graphs, 3.1 should not be all too challenging. That is all there is for this. The final example that I did, this one was not on the note sheet. You can put it on the back if you hadn't done that already. But otherwise, homework 3.1 is on the website, and I hope this video helped.